Welcome and thank you so much for joining us. This video is in regards to graph theory, which is the beginning of network. So networking and graph theory originated from the Koenigsberg's problem. Can a continuous walk to be planned so all bridges are only crossed once? If I try to cross in this problem here, I'm going to have to cross over a bridge a second time to cross every single bridge. And this is where networks came in. Networks came in where we started to think about having vertices. Vertices is talking about land and as riverbeds. So we've got 1, 2, 3, 4 vertices. Then the next part is we've got bridges. And bridges is talking about the edges. So we've got two pathways from between these two vertices. We've got two pathways from these two vertices. And now we are showing that we are crossing each bridge only once. This links into these elements that I just went over. Elements of a graph. We've got vertices, which are riverbanks and islands, edges, which are bridges, degrees, which is the number of edges of each vertex. So, taking away this map, we can form our network. So we had 4 pieces of vertices, which was our land. Then we had our bridges, our pathways between them. So I'm just going to label each of my vertex. I've got vertex A, vertex B, and vertex C, and vertex D. So I had 2 pathways, 2 edges from A to B, 2 pathways between B and C, a pathway connecting C and D, a pathway connecting B and D, and a pathway connecting A and D. This links in now to us really understanding this vocab. So we've said that we've got 4 vertices. Our bridges are our edges. And if you can see on the diagram, we all also refer to them as the pathways. And then we've got our degrees. So the degrees is the number of pathways each a vertice has. How many edges? So if I look at D, I've got 1, 2, 3. So my degrees is 3. With my vertex C, I've got 1, 2, 3. Which means my degree is 3. B, I've got 1, 2, 3, 4, 5. So my degree is 5. And my vertex A is 1, 2, 3. 3 pathways, so my degree is 3. The next step when we are thinking about our networks is really thinking about if they are even vertices or odd vertices. So here I've got slightly different because one of them have got an extra bridge. But this also helps me out when I think about it. So with my D, I've got 1, 2, 3, 4 pathways. Likewise, with my A, I've got 1, 2, 3, 4, 5. My B, I've got 1, 2, 3. And my D, I've got 1, 2, 3, 4. So we are starting to get some even vertices now compared to my odd vertices. We worked out before the odd vertices. If we wanted to do one pathway across every edge, we were unable to. As soon as I have even vertices, I am able to. So I'm going to show that now. So I'm going to start at A and go through to D. I'm going to go all the way up to C. I'm going to go through to A. Continuing my way to C, back to D, and then you can clearly see that I'm able to form one pathway. So this is the difference between even vertice and odd vertice that you'll be able to explore.